It's been a busy summer, so it hasn't just been about the Olympics. So I'm just going to cover sort of a bit of a background of what we do and who we are, in case you don't know. It should be fine. So our summer's been quite an interesting summer. So most people know what we do is our primary reason for building a global network is we do content delivery. So we do, usual suspects. We do RTMP. We do encrypted IMTP if you want for Flash. We do chunk HTTP, both variations, and we also do quite a bit of small object delivery, so for graphics and CCS and things like that. But we've been sort of expanding into digital presence management. So rather than just giving us the Flash file and then you put it into your web, for us to distribute and you can do what you want with it, we'll take the pain away and we'll actually build it into a website for you that makes management and delivery of those objects a lot easier. That has given us the opportunity to get some more interesting information because we now provide, for a lot of people, the player, which gives us some interesting statistics and interesting bits of information. And we've also got a web content management system as well, so people can actually go off and create microsites. And again, it gives us more information and more visibility into what's happening to the content we're delivering on their behalf. And we also have an agile storage platform. Basically, it's lots of disks in boxes, and you can upload content and we'll resync it around the world. We do have a number of the broadcast networks who are doing reports in the UK. Actually, rather than transferring their files back to the other side of the world, what they do is they upload it locally. We copy it across our network, something much quicker than theirs, and then they can download it a few minutes later around the planet. So we did see an awful lot of traffic flying around the place. Not only did we cover the Olympics, we had the Euros, which was very quiet, actually. There wasn't a great deal of people watching it online because it wasn't pay-per-view. It was actually available on mainstream television. It was the right time of day, and people just watched it on their TV or in the pub. We had the Queen's Jubilee, where we saw an awful lot of traffic delivered to Africa. We saw an awful lot of traffic delivered in India on behalf of the BBC, because obviously colonies were doing that. We had quite a bit of traffic delivered to Canada, and we also had some random places in the Caribbean, and obviously the logical places. But we also had an awful lot of traffic in Japan. People in Japan, for some reason, were really interested in the Jubilee. We had Wimbledon. Wimbledon was good for us because it allowed us to test an awful lot of things with the BBC and make sure everything was ready for London. Then not as many people watched it as we expected, but we did manage to get a test number of streams going, and we did see some interesting things. So, I really wanted to do a full slide deck with lots of numbers in it. Then I ran into a few problems. So I can only show some stuff that I'm allowed to show. But one of the interesting things is 21% of all the streams we delivered, not just in the UK, globally, and that means Canada, Germany, France, US, Australia, wherever else we delivered it for, were actually on mobile devices. So that's 21% of the content was consumed on a mobile device. 45% of those streams, though, were on mobile networks, or things we think are mobile networks. We build the information into our player, and it tries to auto-sense and say, you're on a mobile network, I'll tweak your stream so you get a better performance. But only 45% of those mobile devices were definitely on mobile networks. The other 55%, well, 50% were definitely on carrier networks, basically someone who's using it on their wireless on a DSL, or wireless out and about, or in the office. And then we got another 5% where we weren't sure what they were. A couple of those were LTE networks. We did some digging. They're LTE networks. A couple of others purported to be best described as the government. Peaks were very country-specific. Peaks really followed certain events. In Brazil, they watched the beach volleyball, which is sort of understandable. But then again, you've got to remember the time difference, that some of those games of the beach volleyball, they were watching at 5 o'clock in the morning. Just Yeah, that's fine. In the UK, Bradley Wiggins completely managed to get the spike. For whatever reason, it was a Sunday, and the traffic just kept going up and up and up and up and up and up. And at which point we began to go, this could be a problem. And then he finished, and it started going down again, which is good. And in France, they watched an awful lot of judo. They weren't really spikes, but every time there was a judo match on, you could tell the minute the judo coverage started, because the traffic would go up, and then you could see when it stopped, because the traffic would disappear again. So, not quite sure why, but it seemed to be that in France, people watched the judo match for the match, and then just went off, did something else, and came back for the next one. Asia Pac, we saw some traffic, but they didn't really seem to get involved. But again, that could have been time difference. But even the catch-up TV afterwards, there wasn't a great catch-up content that people were doing in the UK, or watching reruns of things through the iPlayer or various other services. This is another graph. This is not my graph, so I can show it. This is the BBC. BBC did some research, and it shows that the traffic sort of did tail off in the second week, but not by much. But what seemed to happen is people realised they could watch it online. They didn't have to watch it on the TV. They didn't have to watch it on the red button. That the BBC's coverage was available online, and they started watching it. And they kept watching it and watching it and watching it. And we had streams that were running for 4, 5, 6, 7, 8, 9, 10 hours in some cases. I think we were having a look, and I think we saw over 10,000 streams that lasted longer than 5 hours. Normally, people watch for 20 minutes on their TV, on the browser by average. There are some long ones and some short ones. So those are available online on the BBC's website, which is quite a nice blog. There's some, lots of statistics on there as well. Right, nothing ever runs smoothly, ever. I guarantee things like this. Today, the mic failed earlier on, and that's it's been absolutely. I've cursed it now, haven't I? So this is a disclaimer. If you recognise the networks I'm about to talk about, it wasn't me. You worked it out yourselves. Okay? I've anonymised them as much as I can, and I didn't say anything about this. And they're not necessarily UK networks. So, network one, reasonable sized network, a network that should know better, that's usually very good, did a fantastic job of upgrading their primary connectivity to us, only for their router to crash and disconnect all the BGP sessions, which was not good. So we then tried to deliver it to them. Unfortunately, the rest of their connections then became saturated. So, moral of the story is upgrade the backup as well as the primary. We did see an amount of traffic shaping. Now, it's not for us to make a decision about how you run an access network. That's your decision. Network 2 decided that what they were going to do is they'd put a hard limit on everybody so that no one could get more than 900 kilobits a second. Now, we run up to about 1.2 meg in normal operation. We do have 1.5 meg streams. We do have a 3 meg stream for various things. But they put a 900 kilobits per second rate limit on it. And you could see that the amount of traffic we delivered to them was slightly less than projected, which worked fine. Network 3 decided they're actually going to be a bit more clever and only put shaping in during the peak. So what they were going to do is it's during the evenings, whenever. Unfortunately, someone made a little bit of a mistake. And the minute that traffic got at all close to being fairly high, you could see the streams clamp down to 120k, which sort of killed them, really. And we had to talk to them and say, what's going on? They were very good. They found the error and they put it up to a nice, reasonable figure. But it was quite annoying that happened during the opening ceremony. Network 4, we're still adding additional capacity on the day of the opening ceremony, which worked great until they had to then borrow optics from us because they discovered they didn't actually have any optics left in their cage. Fortunately, we had a couple of spares in that particular data center, so a couple of access requests later, and that was fixed. So that's it. You know, generally, the Olympics for us just worked, and we were really happy. Traffic levels, traffic level, I've forgotten this one. I forgot to put this in here. We also noticed more traffic than one would expect going to hosting networks. And we are pretty certain we know why. Especially because apparently some people in the US were not happy with the quality of certain coverage. Although, when I say VPNs, I don't actually mean necessarily people watching the BBC's coverage. There were people watching other countries' coverage in places that you didn't expect. So we did notice that some of the Canadians seem to be watching their home coverage from Germany and the UK, which is, you know, fine. But we're going to try and work out how to stop them doing that because we're not meant to do it. So summary, traffic wasn't as high as we expected. It really wasn't. We sort of, you know, the traffic projections made, it wasn't quite that level. However, it was much higher than the last big sporting event. In fact, multiple times higher. And we don't think that's going to change. We think that's going to happen more and more as people just get used to using it. And mobile devices are becoming, you know, everybody has a mobile device. People watching content online over their mobile devices, even if they weren't necessarily watching on a mobile network, they were watching it on their iPads at home, they were watching it on their iPhones at home over a Wi-Fi connection. And stuff happens. Thank you. Right. Any questions? Without, I'm not going to name any networks. And sorry, and before Adrian gets the microphone, or Dave gets the microphone, yes, we delivered content over IPv6, just not in the UK.
Anybody got a non-IPv6 question?
Yes.
Yeah.
David Friedman,
Yes.
Clarinet. What facilities are you making available for your peered service providers to understand the performance of their customers on their network against your content you're delivering?
That's a good question. I hope to be announcing something in February. How's that?
Are you announcing that you're going to be announcing something in February?
No, in February I will be announcing something that I hope is a good thing. Unfortunately, I'm having to wait on delivery from software developers.
Okay, thank you.
Yeah.
Oh, Vlad.
Hi, James.
Yeah.
Do you guys employ any sort
Vlad,
of...
could you introduce yourself?
Yeah, sorry, I'm Vlad Gallo from Inmarsat. Do your systems employ any sort of adaptive transcoding, measuring the available bandwidth to the end user?
Yes.
Okay, thank you.
Okay, thank you.
Okay, thanks, James.
Hi, my name is Mirjam Kuehne. I work for the RIPE NCC. Those of you who were at the RIPE meeting last week, they can go back to whatever they were doing because you've probably seen this before. I added some more details because I looked at the attendees list and I thought there were quite a number of people here who were not at the RIPE meeting. So it's good that we had James go first because this was a nice introduction actually to some of the stats that I want to show you. Just by way of introducing, I just want to talk to you a little bit about what RIPE Labs is because a lot of the data and statistics we're going to be putting on the RIPE Labs website and then just some background on how this all started, where we got the idea from doing this. And then I'm going to concentrate on the European Championship and on the Olympics, just to show you some data there and some conclusions. RIPE Labs, yeah, most of you probably heard this before. It's a website the RIPE NCC has been developing for the last few years. It serves various purposes. One way, it's a good communication tool for us at the RIPE NCC to announce like what we're busy with, what our ideas are, prototypes we're thinking of developing, on new tools or measurements, and to get some feedback from our membership and from the community at large and about what they're thinking about that and if we go in the right direction or not. And on the other hand, it's also a platform for you, for anybody in the community really who's working on some interesting stuff, to put it on the RIPE Labs website. And quite frequently we have external contributions on the RIPE Labs. It's kind of a blog, and everybody can publish their interesting research or any other findings they might have. The website is on that page. That's how it looks like, just a website, and has some comment functionality as well, so that people can leave comments underneath them. It's just like a regular blog as you've seen anywhere else. Yeah, some popular content. It's fairly technical. It's kind of in an operational context. There's a lot of IPv6 related topics, obviously, because that's kind of our core business at the moment. You might have noticed we ran out of IPv4 recently. And so there's a lot of stuff on IPv6. We just published recently an update of an IPv6 CPE survey that we've been doing before, and on popular demand, we've reached out again to some of the vendors and asked them again, like, what features are available on IPv6, and we just published that recently. And some other IPv6 related stuff, an IPv6 matrix that's been done by somebody else, and some other statistics and measurements. Also, a lot of the tools and the prototypes that we're developing, like RIPE Atlas, RIPE Stat, some other smaller tools, they're all available on RIPE Labs, and you can follow the developments there. And then tons of statistics and numbers, because that's what we do mostly, and tons more. So to come to the topic of this talk, it all started in 2010 when EuroIX, well, Serge at the time was at EuroIX, he actually looked at all the exchanges that connecting or that, assembling at EuroIX, and he aggregated all the statistics from all the 51 exchange points there, and looked at traffic patterns during the FIFA at the time. And he found some interesting data, and he published a whole report on that on the EuroIX website, and we just published a snapshot or like a summary on RIPE Labs. And at the time, for instance, was one example at the time, which one was that here? The Milan exchange point actually saw quite an interesting pattern there during some of the games. And then another interesting one was at LoNAP, where they, this is their normal weekday they normally see, and then during one of the games, England versus Slovenia, they actually saw a huge increase there during the game. And you can already see there a little of the typical patterns that we also found later during the European Championship this year. So we thought, well, let's look at the same, let's look at this again during the European Championship this year. And so we reached out to EuroIX again. We're working very closely with Mirjam, and she sent out a mail basically to the exchange points and asked for volunteers to participate in this. And so we got a number of exchange points to send us their data on a daily basis. And then we collected all the data and analyzed it and made some pretty graphs and then put them on the website. So that was nice that they gave us all the data, and so we were looking at some interesting patterns. And during the European Championship, we published quite a number of analysis articles throughout the championship. You can all read them all on Labs if you're interested in it. It was interesting because we got also a number of comments after each of the posts for people from various countries adding some background information, like, in our country, whatever, the games are broadcasted or not, or so I kind of added some background information from or added information that we didn't have, so that was good. Obviously, we don't see everything going through the exchange points, so it's a nice addition to what James has been presenting. Obviously, there are also private interconnects, and I'll get back to that. Actually, we did measure on a small scale what traffic goes through exchange points and which traffic didn't. Right, to get to the pretty graphs, that was one typical pattern that we identified during the games, and it's basically what James also said. The games were in the evening, so people probably watched most of them on television, so the traffic didn't increase much, or at least actually in most cases it dropped, and we identified this kind of double dip during the two halves of the games, and a little bit of a bump during half time. So people apparently got back online and kind of chatted about what happened, or I don't know. That one was Portugal versus the Netherlands at the Portuguese exchange point. So that was quite a dramatic drop. A similar pattern, I showed you this at M6 because M6 is quite a large exchange point, and even there they could see quite a different pattern. You see, I don't know if you can't really see it clearly, but there's some green graph in the background. So we basically looked at the traffic a week before and then the traffic on the day of the games, and basically compared it and checked if there were any significant variations. And we could see a different pattern here. The first one is a game Netherlands versus Denmark, so that apparently people were really interested in watching in the Netherlands. And the second one was Germany versus Portugal, where you can interpret it both ways. I mean, people might do something else, or they did watch only second half or only the first half. I mean, we don't really want to interpret it. It just really shows a different pattern than the other weeks at M6. This one was our favorite exchange point at Samara exchange point in Russia, because they just constantly during the entire championship showed huge peaks in traffic. Now, I don't know what the situation is if the games were broadcast or if they were visible on television or not, but almost all the games showed huge peaks during the actual game. So this one particular one, oh no, what am I talking about? Yes, this is Samara. Yes, this is Spain versus Croatia, I think, that one. So they showed a real big increase in traffic. Another interesting one was in INEX, Ireland versus Italy. Showed also a really big increase for INEX, compared to other days at INEX, at the Irish exchange point. So we could really see this pattern. I mean, it's kind of obvious, but it was kind of nice to see. And either was a big dip, and people went off the internet, watched the games on television, and you could see a little blip in the middle during halftime, or the opposite, people actually watched the game online, and you could see that double bump on the exchange point. You could even see the games with penalties. You could see like a little extension of the traffic wave there. Which one was that? There was Spain, Portugal at the Portuguese exchange point, and in the end Spain won, so unfortunate. But obviously Portugal was very interested in watching that. Probably not online, because it kind of dips down during the evening. Right, so that's what we did for the European Championship. That was a fun thing to do, actually, to kind of look at the internet, look at internet traffic at the exchange points and match it with kind of real life events. So we thought, well, let's do the same for the Olympics. Even though the Olympics were kind of different, obviously, because they weren't at specific times in the evening. They basically went throughout, the whole. They were going on throughout the whole day. And also there were many different sports events going on, so it wasn't just football or just one other type of sport. So we were kind of curious to see if you could actually see anything, like any patterns that we could filter out. And so we tried to look at the traffic and then kind of match it back to what happened during that day. And we found some interesting correlations there. So what we basically did is we looked at, similar to the championship, but we looked at the day, like for instance Mondays, you know, one Monday and then the 2 Mondays before and the 2 Mondays after, and just basically see what a normal day Monday looks like at this exchange point, and then see if it was different during the Olympics. Like this one, for instance. That's low nap, and the red line there on the right-hand side is the opening ceremony on the Friday. It was the first day, and you could see quite a bit of a drop, a bit of a dip during the opening ceremony, because it was an evening. I guess people just went, you know, home and watched it on television, as opposed to this big increase, which was actually during office hours on the Friday after, the next Friday, and you could really see a huge increase there compared to normal days at low nap. And so we look back, it's like, what happened on that particular Friday, on the, what was it, the 3rd of August? And apparently, so my colleagues from the UK, they kind of helped me analyzing and interpreting this. So apparently heptathlon and cycling and tennis is very popular in the UK. So people seem to have watched that in the office or during the day online, because they have no television at work, or however you want to interpret that. Right, so another interesting one, we thought boxing seems to be very popular in Ireland. Currently, 2 big boxing games happened on a Thursday there. The first one was Darren O'Neill on that red line. You can see there was one of the Thursdays, and the next Thursday was the, oops, my arrow dropped down a bit there. Katie Taylor was a big match that people watched apparently online. It was during the day, and 4 o'clock in the afternoon. So there were just some interesting events that we could see. And what we did in the end, so there were just some snapshots I wanted to show you. I'm not going to go through all the graphs. We actually put all the graphs online on a website I have on the slides here also. And that was also interesting to see, because we had all the dates and then all the exchange points, and you can really see what traffic shows on what exchange points are over which day. So it's kind of interesting research to look at that. And yes, one thing I wanted to mention is what I mentioned earlier. It's like obviously not all traffic goes to exchange points, and so we have actually we could add some additional data point there. We have this RIPE Atlas project. I don't know if I know some of you have RIPE Atlas probes even with you here, I saw. But for those of you who don't know what that is the RIPE NCC is handing out, who is that? Who has this Atlas probe there? Alan, can you hold up your Atlas probe? The RIPE NCC is handing out these small hardware tokens, the hardware probes. You plug them into your network, at the exchange, or at home, or at your office, and it sends out active measurements to the network, like pings and trace routes and some others. And then we collect the data back at the RIPE NCC, and you also get to choose your own measurements. You can have user-defined measurements and define the destinations and get your own data collected. And so it actually gives us, we have now roughly like 2,000 of them distributed worldwide, and it gives us quite a good sense of what's going on in the network, and we can use it to debug, or you can use it to debug certain things in your network. So for this particular project, we looked at all the probes that we have distributed in the UK, all 161 of them at the time, and did send trace routes to the BBC website, basically, and just checked which ones went through lone apps and Linksys IP. Yeah, you can question the methodology, but that's what we did. We basically checked how many of them went through one of the exchanges at Links and lone app. And that are the results. So about half of it. Now half of them went other ways, and 28 went through lone app and 55 went through Links. So that was kind of gave us a bit of an idea of how much of the traffic, not how much, but what percentage or what proportion of the traffic went through exchanges, and what we're actually looking at these graphs. I think that was all I wanted to say. Yeah, just as a few words as conclusion. well, it was a fun project. It was really great working with UIX and also with some of the exchange points that participated in this. And yeah, these major sports events seem to have an impact on the internet, but obviously, you know, internet can cope with that, and then nothing really broke. And we did identify some interesting patterns, and it's a question of are there other events that we could, you know, use and look at traffic patterns there, see what impact other events might have on the internet. So if you have any ideas what else we should look at, let me know. And these were all the exchange points that took part. And that's it. There are just some references on the last slide.
Thank you, Mirjam.
Thank you. Are there any questions?
Any questions? Okay.
The other Adrian.
Thanks. Adrian Farrell. There's a requirement that somebody called Adrian asks a question every session. Really for you and James, what impact are you seeing from multicast, if at all? That was a 0 at this end, is that?
Okay, yeah, we didn't look at that.
Okay.
Sorry.
Yeah, we're seeing the only places that multicast is having any impact at all is controlled environments such as student housing, where they're providing a multicast feed of television to set-top boxes where they control end-to-end, and occasionally in hotels. We're not actually seeing inter-provider having any real impact.
Do you actually provide it as a service?
If anybody asked us for us, we could. We just haven't been asked for it in 10 plus years.
I don't see
Any more questions?
Okay, thank you.
Okay, thank you, Mirjam.